JJL Civil was approached to design an industrial portal frame warehouse situated in Wollongong in compliance with Australian standards and the client requirements. In response to the client as shown on the right, the design follows a specified length, eave height, etc., incorporating a mezzanine, 10 windows, a roller door, and accompanying access doors. During our design process, we've instead added 16 casement windows and skylights installed high to improve ventilation, heat management, and natural sunlight. We've added the roller door to be in the center and the two doors divided on both ends of the frame for ease of access and fire safety. For the structural framing, restrained 305 x 165 x 40 UB columns and 254 x 102 x 22 UB rafters were chosen to support the design's 8 kN per meter rafter load, 7 meter eave height, and 12 meter span. The columns are laterally restrained by girts and the mezzanine, with the portal frame spaced 5 meters apart to stay within the required 4.5 to 6 meter range to give the system its strength and stability.
Continuing with safety, the placement of the windows was a deliberate decision by our company. This choice was based on the potential machinery that would be travelling in and out of the warehouse. The risk of vehicles or equipment hitting and smashing glass windows is significantly reduced. Additionally, the privacy of the client's business movement is hidden from onlookers. The warehouse notably owns a low-sloping roof of 6 degrees, which provides the client with a perfect opportunity to safely and efficiently install solar panels if they wish to do so in the future. Having a low-pitched roof is considered of making maintenance work be safer for personnel to move on.
As you can see under the mezzanine, as an innovative component, structural supports were added underneath the mezzanine in order to be able to withstand larger loads placed upon it, making it both safer and be used for larger items. In order for the structure to be soundly supported and be able to uphold and attach the steel panelling on both the wall and the roof, it was decided that the purlins were to be the Z style, as they are most suitable to withstand larger loads and are easy for construction, whereas the girts were made to be the C-channel style, as they are better for supporting loads and spanning across larger sections. The type of purlin and girts were chosen from the Lysort section property span table that you can see here, which included the ZNC 25024. These were selected due to its high strength to weight ratio whilst not exceeding the maximum loading capacity of the rafters. As per client specifications, the roof cladding consisted of the Lysort Clip-Lock Classic 700 panelling. The type of material selected for the panelling chosen was the colorbond steel due to its durability and cost effectiveness. Due to the region this warehouse is in, it was decided that the 0.42mm thickness was best suitable, as it was a lighter material but could still withstand a wind load of more than 1 kN per meter. The wall cladding was chosen from the Lysort spandeck material selection with a thickness of 0.42mm, as it was suitable to withstand the environment around and be able to span across larger areas, ensuring the most cost-effective option.
In evaluation of the prior Revit models, the team produced a structural model of the internal portal frame using space gas in 2D and 3D as shown of the preliminary design. In transference between preliminary Revit models, selected beams and columns were re-identified to account for the available space gas element changes as shown. Haunches were added at this stage, 1.8 metres each side with 2 sections, as well as fly bracing for the purlins. Primary load cases as seen here were extracted from the 3D model and all load combinations were produced. These included 1 serviceability limit states and 4 strength limit states for the structural analysis to be performed for Region B2 Wollongong location. All are in accordance with Australian and New Zealand Standard 1170 for the design load combinations to check that this structure is within regulations with location-specific loading, a critical step forward for this project. Further technical design aspects were also completed at this stage, including the apex rafter to column and column to concrete connections using the pictured elements. Final extensive evaluations, including buckling analysis and member checks, will be presented as part of the final JJL Civil Engineering Specification Report, which may include minor adjustments to comply with all design criteria and Australian regulations.